Are you just that fun song? Oh, I just know you don't do it. No, you're not in geometry. Sorry. Sorry. You can just like leave, give them. All right, guys, you need notes.
Hey, Charlie, you gonna get the note from the love. Up there. Guys, bring it down.
Look, I know you're very excited about today, but you got to chill, okay? Hey, come here, baby. Yeah, you're the extra player.
Hey, can you bring it down?
All right. I'm going to go ahead and start talking now. All right. Thank you. Okay. So today starts your analytic trig unit. It is challenging. You'll be frustrated. You will want to beat your face on the desk. Do you? But you need to keep going. Okay. They can be a little intimidating. But the cool thing is like once you see a bunch of them, you will know all the tricks. Right? But if you don't ever try any, you're not going to learn the tricks. But after a while, they become repetitive. Right? After you've seen enough of the tricks, then you can pretty much do it all. If you're rusty on factoring, we have got to fix that because we're going to factor with the trig expression. So if you know you are rusty on factoring and you would like some practice in Delta or something like that, I'll be happy to assign it on so you can work on that. So, and one thing about today, while I'm teaching you these, I will probably do 2 passes on some of them. You know how I do, I'll walk through and then I'll go back through and explain step by step. I want you to ask me questions when I'm going through on the second try, okay? And you're gonna be like, well, where did that come from? Because that'll happen some. The main challenge in this is a lack of algebraic manipulation skills. That is all it is, and that's kind of the whole point of doing this. It's just algebra with weird things, that's all. So, think rationals, factoring, all of those things, but with a bunch of weird Greek letters and sine, cosine, tangent, etc. Okay? But like I said, try, and I will help you. Like it says over there, you have to start somewhere. Sometimes you just got to start over. And in general, you start over when it starts to get worse. Okay, if you're working on it and things are getting worse and not better, you probably have done something that is not the most efficient way to solve one of these. Okay, so even when you're frustrated, you just got to keep going, and eventually it will click. And I will tell you when it finally clicks, you're like, oh yes. So there, dopamine. But there are a lot of different ways to get there. You can go the long way or the short way or whatever, but we got a bunch of different ways. These are not going to make sense to you until later, so I'm not even going to bother. I just need you to, write some things now. So basically, it says the goal up here, again, you're not going to know what I'm talking about until you see an example. So right now, you're just going to copy things, okay? We're just copying them right now. So there are some reciprocal identities, and cool, we already know these. The sine of theta is equal to 1 over, do you remember what goes with sine, the reciprocal?
2.
No, you don't. I didn't answer my question clearly, cosecant. What about what goes with cosine? Secant, right? And what goes with tangent? Beautiful. All right, so half the battle is kind of done with that. And then we'll go the other way just so we have them all there. So I can rewrite cosecant as 1 over sine. I can rewrite secant as 1 over what? Cosine. And I can rewrite the cotangent as 1 over tangent. These are somewhat familiar to us, right? So basically, we're just going to be replacing things to try to make one thing look like the other, and there are some rules that I'll explain. So these are the reciprocal identities. We call them reciprocal identities because, They're reciprocals, and we are not creative. So the tangent identities, I also call these the quotient identities, aka quotient. You'll hear me say use a quotient identity, aka quotient identities. It's just a difference in terminology. We already kind of know these too. The tangent of theta can be rewritten as the sine of theta divided by the cosine of theta. Is this ringing a bell somewhat? Kind of remember? Okay. And then also the cotangent of theta can be written as the cosine divided by the sine, which makes sense because cotangent is just the reciprocal of tangent. So we just flip that thing over, right? So these are the tangent or quotient identities. And then this one is going to be new to you, the Pythagorean identities, but it's really one of the most powerful. It is the sine squared plus the cosine squared equals 1. And as a side note, I'm going to write something in blue that kind of translates this because this notation is maybe new to us since we haven't seen these functions squared. What this really means is I just take the sine and square it, and I take the cosine and square it. And we just write it like this. We write it like this just for clarity, right? Because I don't want to have to do this parentheses, trash, I'm lazy. I don't want to have to write it like this. And if I put the square there, you might think that theta is squared, and that's not it. It's the entire function. So when we situate the exponent here, you need to see this in the head, okay? I just take the cosine, and I square that whole thing. So if it's the cosine of 45, that would be the square root of 2 over 2, and just square that. So this means this, okay? Well, what it is an identity, it's just something that's always true. Always and forever, like 2 plus 2 equals 4. Always true. And so this is kind of the same thing. Take an angle, square the sine of it, add it to the square of the cosine, and you're going to get 1. And we'll actually prove that later. And maybe you'll be as amazed as I was the first time I saw it. Maybe not. Who knows? All right, so let's take a look at some examples. Has everybody got these? Okay, cool. Actually, let's go back to the first one. So I want to do one more thing. One more thing that you can do with this. So this is one of the identities. This is the main one. But using the miracles of algebra, I can solve this for sine theta. See if you can figure out what I'm doing. What did I do there?
You put sine squared.
Yeah, I just isolated sine squared by subtracting the cosine away, right? And so you'll see later why this is pretty useful. So can we isolate the cosine? Sure. Let's just leave cosine alone. And we'll have 1 minus sine squared. This is another couple of identities here. You can build everything off that first one that's in red. Okay, real quick. Does everybody understand how I got the second 2 from the first one? If you don't, I need to know. Because this is a critical skill for us. Okay? Being able to isolate one way or the other. So these things behave just like numbers or variables or whatever. They're stuck together. So if I want sine squared by itself, I just subtract cosine squared from both sides and I end up here. What?
I just got those.
Okay, good. So we're good here so far. Yeah. Okay. So now let's proceed to do some examples. And there's some really important things about how you work one of these, and I'm going to yell at you a lot about it because you're going to be like, it's an equation, I'm going to do it on both sides. Because normally when we see an equation like this, if I do it to one side, I have to do it to the other. Does not what we are doing. Okay? What we are doing is we are manipulating the left of the equal sign to make it look like the right-hand side. So notice in example A, on the right-hand side is 1. I do not touch that 1. That is like my destination. That is where I'm trying to go. I don't mess with it. I'm just trying to make the left look like that by replacing things with identities. And so let me show you how this first one works. And this is the first of your like tricks that you're going to want to try to use. So because sine and cosine are like the basis of everything, a trick that works a lot is to make everything into sine and cosine using the identities. So remember, I told you that cosecant can be rewritten as 1 over sine. Agree? You with me? Okay, and then I have times sine of theta. And remember, do not touch the equals 1. It just comes down with us. We're not touching it. All right, so now I have these fraction type things. So remember, when I multiply fractions, I just multiply across the top and the bottom. So this will actually be sine theta divided by sine theta. And of course, these two things will, simplify. Yes, sir.
Don't you also notice that sine of 1 over sine theta is sine of theta to the negative 1?
Yes.
You could cancel that with
Yes,
negative.
you can do that as well. Sure. So sine theta divided by sine theta is simply 1. So now notice that the left-hand side has been transformed to look like the right-hand side, and that is considered to be verified. Because this is an identity. It is always true, right? 1 is equal to 1. Done. Okay? Let's do, yeah.
How did you get 1 over sine?
So I used a reciprocal identity. So if you look, right, so if you look on that first page and look
I
on
thought
the,
it said cosine.
oh, you're good. I just replaced this in terms of sine, and then I combine these two, cancel, that's a 1.
So if they don't equal 1, it's not verified?
Both the left side must equal the right side for it to be verified. It's not always going to be 1, like if you notice in example B, we're trying to make that left-hand side look like cosine. And so, and when I'm looking at B, so I'm looking at it and I'm like, okay, the first thing I notice is there's like a 1 minus something squared, or there's like anytime you see something like that, subtraction, addition, you should immediately think Pythagorean identity, okay? So look on the front page, look at the Pythagorean identities, and see what we can replace 1 minus sine squared with. What is equal to 1 minus sine squared? Oh, cosine squared. So I'm going to just take this out and put cosine squared theta in its place. And then I'll have times the secant of theta. And remember, the equals cosine stays forever and ever and ever. So that's step number 1. I'm closer now. I got rid of that pesky subtraction. I didn't like that. So now let's go back to the trick I taught you in A, where we change everything into terms of sine and cosine. So this is already a cosine. I'm not going to mess with it. Secant can be rewritten as 1 over cosine. There you go. Then I can multiply straight across and I'll have cosine squared divided by cosine. And so what you should be thinking, and I'm gonna do this in a different color. This can be interpreted as cosine theta times cosine theta, because something squared is just it twice, right? So really that's what this is. So I can cancel 1, right? Okay, so that's why I'm going to do this, and I'm going to write, I'll have a cosine remaining on top. So really, it's easy for me just to take that exponent down to 1 and mark out one of the cosines. But what really happened here is I had cosine theta twice over cosine. One of them canceled and I ended up in. So notice now the left is equal to the right. Are we verified?
Yes.
Yes. I know to stop now. Right. Questions about number B or letter B? Yes, so this is understood, so it's a good question. So remember that when we are working with fractions, we need them both to be fractions sometimes. So you would just understand that there's a 1 on the bottom. All right, so if there's nothing on the bottom, you assume it's on the top. Okay, if you don't see anything, that's that hidden 1 in the bottom of the fraction. So, all right, let's go again. C, cotangent times sine. And so when I'm looking at this, I'm like, well, I don't see any adding or subtracting, so I'm not really going to mess with the Pythagorean identity first. That's that 1 minus or the sine plus cosine. I'm going to go ahead and change things into terms of sine and cosine, which is the trick I've been using a lot so far. So cotangent, using a quotient identity from the first page, I'm going to flip back over and look. Cotangent is actually written as cosine divided by sine. Then I'll have times sine. We would understand that there's a 1 under there equals cosine theta. If we multiply straight across, we'll have cosine theta sine theta over sine theta. And it's going to cancel, right? You're going to cancel out one of those signs. Boop, boop. And you're left with just cosine in the numerator. And I verified. Yay, nay? Yes. Okay. So ask me questions about C. If you're not understanding why I chose to do something or how I got somewhere or anything like that. Okay. 25. Excellent. It will get,
Progression.
it starts out okay and then
They're kind of just like two-step equations.
But if you can do this, then, I have lots of hope for us.
When you share the equation, can you simplify it in a different way and still, as long as both sides of the.
Correct. There are multiple pathways, right? So, well, I'm gonna do it one way, right? But you should not be concerned if you do it a different way. But as long as you end up here and the steps you took are valid steps, then I don't care how you get here. It doesn't matter. Right? It may be longer, it may be shorter, some of you guys may find a better way to do it than I do it. I don't really care. But please do not sit there and be like, oh, this is easy, I'm about to zone out. You're gonna look back and be like, my God. Please, all right? So let's go again. I was talking to you. All right. Now in D, I'm about to blow your mind. Okay? So I'm going to do D, and I'm not going to say anything. And I want you to watch me and see if you can figure out what I'm doing, okay? And then I'm going to go back and explain it. So I'm going to look, I'm like, all right, what am I dealing with here? Well, I'm going to do this. Just keep it to yourself. I want you to see if you can figure out what I'm doing. Where I'm not touching the right, just the left. All right. So, okay. So I look at this one, what did I do in, disregard this, what did I do right? I did not use an identity.
Well, maybe you just realize that that's a negative sign, so you left some from it and used one.
Miss Apple?
Yes, ma'am.
Hey, can you send Scarlett Haley to Mr. Miller's office on J Hall?
Yes, ma'am, she's on her way. Oh, I got her here. I factored out a sign. This is a common factor. Okay. So I noticed that there was some subtraction. And I noticed this is another trick to add to your toolbox, okay? If I did a Pythagorean identity here, it would get more complicated. But I did notice that there are two terms. Remember, a term is something added or subtracted, and that this is in both of them, right? So just like anything else, I can factor that out. If I factor a sign out, this is left as a 1 minus, and then the cosine squared is 1. You see what I did? Or yeah. All right, let me do it with, so let me use this example. Let's say I had x minus xy squared. And I factor out an x. I would have x 1 minus y squared, right? You with me?
Yes.
No.
Yes. Somewhat.
How about, let's try it again like this. If those of you that are yes, good, let's pick up everybody else. So,
Wait, is it because there's an invisible 1 next to it?
yes, because there's an understood 1. Is it the 1 that's found you out? Okay, look. There's a 1 right here, right? There's a 1 right here, always. So if I factor this out, it doesn't just disappear. There's a 1 remaining.
Yeah, keep this on.
What?
That negative goes this side.
This negative applied, this is one whole thing. This is like a 2x squared. Let's say I just pulled that 2 right out. So like this would be also similar to 2 minus 2x squared. Factor out the 2, you're left with 1 minus x.
Aside from each one.
Yeah.
Just one.
She took out, you see that minus sign.
Because this is two things. This does not just disappear. This whole thing doesn't just go poof,
So
gone.
still gonna have a placeholder?
You can think of it as a
So
placeholder.
there's an imaginary one.
Yes. Because
Understood.
Yes.
Imaginary.
like when we knew it was there, we didn't really know it, right?
Imaginary, these ones are really.
When it's 1 minus something, it's got to stop. We'll revisit with, I'm gonna show you some stuff with some letters. Okay. All right. What did I do in the second step? That 1 minus cosine squared, where'd it go?
You change it for software, but.
Pythagorean identity. And then what happened here? How did I do this?
You multiply by the others and you add.
Combine like terms. Explorer rule, yay, 1 plus 2 is 3. There are 2 of them here, 1 of them here, so 3 times. All right? So you see how I'm telling you it's the algebra that is going to get you, not the trick. It's the algebra. All right, I'm going to show you one more trick. Show you one more trick.
Cosecant over cotangent.
All right. So in E, here's how I'm going to. Huh?
I chair and I turned the AC on.
Thanks.
Thank you.
Thank you.
Don't turn it off.
Let's focus. Let's focus back in. E. Watch what I'm doing and see if you can follow what I'm doing, okay? So this will be cosecant theta. And there's more than one way to do this. But this is how I like to do it. 1 over cotangent theta equals secant theta. So this will then be cosecant times tangent. This is one of those where there are a lot of ways you can do it, but this to me is the easiest. At this point, I'm like, ooh, okay, I would really like to turn these into sines and cosines because that's gonna be my like ace in the hole trick every time. This will be 1 over sine. And then tangent is sine over cosine, right? Can you start to see how it's gonna go? Okay. Can I cancel anything?
Sine.
Yes. Oop.
Oh, and then 1 over
Yeah,
cosine.
Yes, there you
And then
go.
there's
So
one
1
over
over.
cosine.
Yes.
Okay.
So there's 1 over cosine is remaining equals secant of theta. And what identity can I use here? Like one on the front page, what's it called? A reciprocal identity.
Reciprocal.
Yeehaw. So this will be 1 over cosine is secant. And look at there. The left equals the right, and we are verified.
At the beginning, did you multiply the cotangent over?
Okay, so what I did is I call this splitting the fraction.
Okay.
Because guess what I don't like to have to deal with, and that's keep, change, flip. Me and division are not friends. I like multiplication, it's easier. So because this is in the denominator, I really just separate it. Because if I were to go backwards here, I would just multiply straight across and I would be right back here. So it's cool that I did this. This is a nice trick.
You made it easy to look at.
It is easier to look at, yes. Because otherwise you would have to flip it and multiply, which really this is directly that step. Because if you were to divide by the reciprocal, that's what you have.
And then it's just easier to see like that you can turn.
It's easier to see, yes,
Okay.
where you can go because you've separated them, so you're not looking so much. And so from here, I'm like, okay, well, I definitely don't like that. I don't want 1 over anything. So I'm gonna turn it into tangent. And then I'm gonna be like, okay, here's my trick. I'm gonna turn it into sines and
We have
cosines.
x2.
Then I've got something. Once you start canceling stuff, you can feel good that is going how you need it to, because if it's canceling, it's simplified. And from here, I just have 1 over cosine, which is secant, which is where I'm trying to go.
So if it's a fraction, you can just like slide them apart
Yes.
to 1.
As long as do not put this on top, it cannot just travel to the top, it has to be 1 over because it stays in the denominator. And you can't just magically like, oh, it's at the top now.
So basically, what you do is
One question,
you find the equation that fits in, and then you just move.
you just swap it out. You find something that fits and then you just swap it out with that. Like here, I took out 1 over cotangent and replaced it with tangent because that is equivalent based on the reciprocal identity. Here, I just removed tangent and replaced it with this. And it just makes things fit together nicer.
So did you just like separate cosecant and cotangent? Like this? So you just like put it in the corner?
Because if you were just to multiply this straight across, would you not have this? Would you? Well, cosecant times cosecant and 1 times cotangent is cotangent. So now we're getting into this, I'm gonna work backwards, it works that way, it's fine. You just gotta get used to it. Eventually you'll see this and be like, choo. Okay? Ross, you had a question?
Oh, no, cause, wait, 'cause you can't change the secant on the right,
No, you cannot touch this.
like at all?
Nope.
Okay. Cause I was thinking, what, couldn't you just change it 1 over cosine, just drop it out?
That is an improper verification. We do not touch the right-hand side. That is our GPS, right? That's where we're going. Do not touch it. What did I say I was gonna do if you did that?
GPS. Mark it on.
Yell it,
Oh, I don't wanna be yelled at, so I'll just keep it.
make fun of you. Yeah.
Yay.
Hey.
So,
Bring
all
me
right.
the whole bully.
We're not doing that.
But why does the math do that?
Why do the math do that?
The math does that, but why does the math do that?
That is an existentialist question reserved for a philosophy.
Because some guy made the rule like hundreds of years ago.
Why do the math do that? I'll tell you why we had to do that, because the calculus is.
Because it's on the test. It's on the
Yeah.
test.
Because you have to graduate.
All right, let's keep going, please. I don't want to talk all day. This is boring. All right, here we go. Example number 2. Let's prove the Pythagorean identity. So let's remember what that is. That's sine squared theta plus cosine squared theta equals 1. Like the holy grail of the identity. It's like So let me remind you of a couple of things real quick. I'm gonna draw a picture. This will be the unit circle. I'm gonna show you some stuff real quick. So you just draw a junkie circle since you don't have like my advanced tools up here. So I'm just gonna draw a real quick unit circle. So you should be drawing what I'm drawing.
Yeah.
It's okay if it's junky as long as you can tell what it's doing. And let's see if we remember. You remember that the coordinates of that point on the unit circle is sine, comma, or cosine, comma, sine. Do you remember this?
Yes.
Okay. Somewhat? Okay. So let's look at this triangle that's made right here. This is a right triangle, right? Correct?
Is that just a squared plus b squared?
Ah, yes. Okay, so let's also remember that if cosine is the horizontal distance to that point, that means this side of the triangle is equal to the cosine of theta. Are we good?
Yes.
That means this vertical side is equal to what?
The sine.
The sine of theta. And what is the radius length of the unit
1.
circle? 1. Well, now let's do this. What is the Pythagorean theorem?
A squared plus b squared.
Very good. Okay. And A and B are just the legs of a right triangle, and C is the hypotenuse, correct?
Yes.
Well, what are the two legs of this triangle?
Cosine and sine.
Cosine and sine. So this is
Cosine squared.
cosine theta squared plus
Sine theta
sine. Let
squared.
me reverse it. It doesn't matter, but just to keep it nice and neat. So one of the legs is sine. One of the legs is cosine. And the hypotenuse is
1
squared. Well, there's the Pythagorean identity, and that is why it is true. We just did a proof. Congratulations. Ask me some questions about this one. Are you with me about how I got the A and the B and the C? Cool. You just proved the Pythagorean identity. All right, so let me explain something. In this section under X1, these are the kind of problems I need you to know how to do. This is a conceptual question to help you understand where those came from. And the example 3 is us creating new identities that you can then just memorize if you want to. But it's important that you know where they come from. So this is not a type of problem that I'll be like, you've never seen this before, now prove this. No, this is a conceptual background. You're going to be doing those verifications. So don't freak out when I do what I'm about to do, because you're going to be like, how'd you know how to do that? Well, somebody that was really bored sat around and was like, I bet you I can come up with some more of these. And they sat there for weeks and came up with what I'm about to do. You're not expected to be like, I can come up with this. But you do need to understand it. So let's take the Pythagorean identity and let's create another set of identities that relate some different functions, because we work with just more than just sine and cosine, right? So I'm going to make some more identities that we'll use. So the way I'm going to do that is I'm just going to be like, all right, man, I'm going to divide this entire identity by, I forgot the theta. My bad. Give me a break. Let's divide everything by sine squared of theta. And we're going to get a brand new relationship here. So remember, when I divide by something like this, I divide it into each term, right?
Yes.
Okay, so let's write the next step. That's going to be sine squared divided by sine squared plus cosine squared divided by sine squared equals 1 over sine squared. Now, let's clean this up a little bit. I'm gonna give you a second to write it down. I don't want you getting lost.
Wouldn't it be 1 plus tan equals 1 over sine squared theta?
Close, not tangent. So let's look at this first term right here. What is that gonna simplify to? 1. Can we replace cosine squared divided by sine squared? With what? With cotangent squared. I need you to understand that if they're squared, they stay squared. And so then what would 1 over sine squared be? Cosecant squared theta. So look, I have this brand new identity that you'll need to know. I'm not a memorizer, so I just derive it. I remember the first one, the sine plus cosine, but I can derive the other ones if I forget them. That's why I show you how to do this.
So that's equal each other? That's equal each other?
1 plus cotangent squared equals cosecant squared forever. Huh? This is another identity. Can you just memorize this identity? Yes. Or you can remember this process, whatever. Let's do it again. Except this time, I want you to try this same process except with cosine squared to get yet another identity. Okay, so this time I want you to divide the entire thing by cosine squared. Let's see how you do. I'm going to give you a couple minutes. We're going to get another new identity from it. All right, if I highlight it in yellow, maybe you want to draw a box around it or something because you'll need it. I'm going to start silently working it out. So if you're still working, I'll interrupt you. If you want to if you finish and you want to take a look and see if you got the same identity I did. Got it?
I got a question.
Yes.
But that one,
I got somebody with a question. You might have the same one, so listen.
there's the other one on the left, you got the cosine squared.
Here.
So on the left, you got cotangent with that, with cosine.
This?
Yes. How'd you get tangent without that?
Now notice the difference, sine over cosine versus cosine over sine. So here sine is on bottom, here sine is on top.
So when sine's on top is tangent, when sine's on bottom is cotangent.
So for like 1 over sine, like the first one 1 over sine, and then you have the cosine, does it matter how we write it at the very end? Like if we did 1 plus cotangent equals 1 over sine, would that be wrong since it's technically?
It's not wrong, it's not going to help you because it doesn't explicitly make the connection. Because the power of this, the power of this, remember we have 6 trig functions, sine, cosine, tangent, cotangent, cosecant, and secant. With the introduction of these 2 new identities, we now have all covered. We have sine, cosine, tangent, secant, cosecant, cotangent. And so we have an identity that addresses all six, right? So is it wrong? No, but it is not as helpful as it could be, right? So this is the identity that's going to be most helpful.
Wait, I'm okay.
Yep.
Where, okay, in the original problem, like first line, square, yeah, that one. There are only 4 sides, but then whenever you do it like that, there's 6 sides.
What?
Like it's sine squared over sine squared.
So when I divide an entire equation by something, I just put it in each one. So there's not
Oh,
more.
duh, okay.
Okay, that's, I mean, I guess if you don't know why I did something, ask. Good so far? Okay. We do another thing with you. So do you remember on the first page when I isolated sine and cosine? Remember the algebra? We need to do this here too. So we need to isolate the one and then isolate the cotangent. You know, miracles of high school algebra and all. So let's write the other ones. Do you know what I'm talking about when I say that? Let me show you on the first page. I want to do that again. Remember right here when I found these other two, just by isolating different pieces. So I want to do that down here. Let's isolate the one. So that would be 1 equals cosecant minus cotangent. Right. These follow the normal rules of algebra. Except we have something different isolated now, which gives us more power when we're trying to solve different problems and replace different pieces. And now let's isolate the cotangent. And you can kind of see why we would want to do that, because, if I need to replace cotangent, it's pretty easy to do that when it's solved like this, right? If it isn't solved like this, then you might have a problem. And when you're first working with these, you really just need to be able to look at them and be like, okie dokie, what can I replace here? So I'm going to isolate tangent squared now. So this would be secant squared, then what? Minus 1. And now I'll isolate 1. Be secant squared minus tangent squared. So I got a lot of options. So everything that I've highlighted in yellow are little tools for you to use when you're manipulating these things. Okay? I'm going to give you a second. And then we're almost done, and then you're going to practice and become frustrated, and then let me help you. Yes.
Whatever one's on the outside of the equal sign, that's the one you're going to be subtracting from. So how secant is on the outside, it's always going to be secant first and subtract whatever it is.
Yeah. Because if not, you can't reverse the order of subtraction without factoring out a -1 or something. But these are all more tricks that we'll learn. Yes, ma'am.
So I think we just subtract secant and then divide by the negative.
You can. You can do that. Sure. There's lots more you can do, but these I find to be the most basic set of tools, right? And we can do all kinds of stuff, but the paper gonna fill up quick, all right? But these are the most basic. All right, let's verify the things we just found. So remember, what's the rule when you see the word verify? What can't you touch?
The right side.
Do not touch the right-hand side. So this one's gonna blow your mind. See if you can follow what I'm doing. This will be 1 plus cotangent is cosine. You're just gonna see if you can follow me, because I'm gonna go back over it. Because this is gonna be like, oh no. I told you. But see if you can figure out what I'm doing, even if you're not writing. See if you can follow, because you'll have time to write in just a second. Oh, wait, no. This will be sine squared plus cosine squared over sine squared equals cosine squared. 1. And then last step, we're there. So this is another trick for your toolbox. All right, let's see if we can talk about what I did here. Remember what I said, it's the algebra that will get you, and knowing what you can and can't do. All right, so the first thing is kind of obvious what I did. I took the cotangent and put it in terms of sine and cosine. Did you hear? What is that?
That's the one.
The 1. Why do you think I did that?
Because it's easier to see signs.
It's easier to see the signs, but also I needed a common denominator. Because if you notice on the left, I have an addition, and over here, there's just one thing. There's 2 over here, and there's 1 over here. And the bridge between something added and nothing added is gonna be that Pythagorean identity. So if I got something crazy like this, then I'm gonna take it and combine. So once I combine, remember when I have 2 like denominators, I just take the denominator and combine the top into a new numerator. Remember this? Rationals. And then, I mean, when you see this, you should just be like, that's money, right? Because this right here is so simple, it's a 1. So this very complex sine squared plus cosine can be replaced with a 1 with the primary Pythagorean identity. So that became a 1, and then we're there. You cannot, because of this. Remember, this is locked in. We can only cancel things that are multiplied. This is not multiplied. So instead, I'll make that a 1, so that's y, right? Let's go again. Yes. Question.
So how do you go from that first step that you were on to the whole sine squared over sine squared? Can you just do 2 now?
So let me show you in blue. Remember also, like, you can write 1 however you want. You can do like truck over truck, and it's 1. You can do 4 over 4. You can do cosine over cosine. You can do sine over sine, whatever you need. But it's really just finding a common denominator, because let's look. If this is a 1, what is this denominator missing that this one has? But if you do it to the bottom, you must do it to the top. So that's where it came from.
So it all
Better?
just,
That makes sense.
it all just relies on the other denominator?
Mhm.
Okay.
Yep, you just have to have identical denominators in order to do that. All right, I'm gonna verify one more for you, and then we're gonna practice and be frustrated, okay? If it's cool, I will help you. All right, we're gonna do the same thing here. Tangent can be rewritten in terms of sine and cosine as sine over cosine, right? Sine squared over cosine squared. Plus, yeah, you got it. You can go ahead and skip that step if you can. So the next step would be, I want to combine these 2 things. How at this step do I know that I want to combine? Like, how do I know to do that? How do I know that I want to combine this? It's addition, and do we have addition over here? No. So we have to use some trick to get from something with addition to something without it, and the Pythagorean identity is the bridge. And in order to get this together, I need to find a common denominator so I can have 1 fraction instead of 2. Okay? So that's one of my hints that tells me where to go. I have addition and I don't want it. So I need to combine those 2 things. So how am I going to rewrite that 1? Cosine squared over cosine squared. Come on. And then remember, when I combine the 2 fractions, I'm going to write them with the same common denominator, and I'm just going to combine the top, and look what's about to happen. Money. Money. That's a 1 on top. When you see this, you should be very happy. Okay, if you can get that first 1. All right, you see it kind of unfolding now? Whenever cosine squared.
I'm proud of myself.
You should be proud of yourself. These are hard.
These are easier than the numbers.
I agree.
They are easy.
Now, okay, it's my job to make it look easy. Because figuring out which strategy to use is going to be your challenge, right? Because for a minute, it's gonna feel like you're blindfolded and you can't get to where you need to go. That's why under encouraging words, it says just try some. And eventually you will have worked every type of problem and it will be repetitive. But the first go around, you're gonna be like, ugh, and that's normal. All right. I'm gonna give you your assignment and you're gonna work on it. I want you to,